Okay, so welcome to part 2 of simplifying rational expressions. Okay, so last lesson we talked about how we can simplify rational expressions the same way that we can simplify rational numbers. So we're going to continue with that, except we're going to be looking at more complex examples. So in class example number 1, we're just going to do B. And so the first thing they ask us is reduce to lowest terms, stating the restrictions on the variable. So we remember that the restrictions are the non-permissibles. You can read my writing. And this is what we want to do first. And then we reduce to lowest terms. So for this one here, to find those non-permissibles, we have to factor our denominator. So let's do that first. So I'm actually going to write bottom, and I'll show how we can factor that. So this is a type 2 factoring problem. So this is when we go, okay, so what plus what is equal to 1, and what times what is equal to negative 2. And so we get negative, or we get positive 2 and negative 1. So we know then, okay, we go 2x squared plus 2x minus x minus 1. And from there, we can go, okay, well, 2x, x plus 1, minus 1, x plus 1. So we know our two factors on the bottom are 2x minus 1 and x plus 1. So right from here, this is where we can find our non-permissibles. So let's go do that. We'll go 2x minus 1 cannot equal 0. So we know that x cannot equal 1/2, and x plus 1 cannot equal 0. So x cannot equal a negative 1. Okay, and these are our two non-permissibles. Okay, but so we've done the first part. Now let's reduce to lowest term. So our bottom is all factored, but let's do our top now as well. So what plus what is equal to 5? What times what is equal to negative 6? Okay, so we have, okay, we have 6 and negative 1. That adds to 5. And 6 and negative 1 multiplies to negative 6 as well. So that gives us 2x squared plus 6x minus 3. We can go, okay, well, 2x, x plus 3, minus 1, x plus 3, which gives us our two factors, 2x minus 1 and x plus 3. So then, altogether, we know that our equation, maybe do a dotted line like that, altogether our equation is, looks like this. All over 2x minus 1, x plus 1. Okay? And then we can look at it and say, oh, well, these can divide out. So in simplest form or in lowest terms, our equation is x plus 3 over x plus 1, like that. And our non-permissibles are 1/2 and negative 1. Okay? So if we go down to example number 2, we can do all three of these. And so it asks the same thing. It says express in simplest form, stating the values of the variable for which the expression is not defined. So first we find the non-permissibles, then we express it in simplest form. So for A, let's go, okay, so 4 minus C cannot equal 0 for our non-permissibles. So that means 4 cannot equal C. And then to state it in simplest form, we can go, okay, well, here we have a positive C, and here we have a negative C. So if we are to go like this, imagine we go C minus 4 over negative 4 plus C. So all we did was divide the denominator by negative 1, and that gives us C minus 4 over negative t minus 4. And then we can cancel these out. And that gives us 1 over negative 1. So negative 1 is our final answer. So if you see something like this where they kind of look like they're opposite, try dividing either the numerator or the denominator by negative 1, and there's a good chance that something might be able to cancel out. So let's look at B. So we have, okay, let's find our non-permissibles first. So we'll go 16 minus 8p cannot equal 0. So we get 16 cannot equal 8p, and we get that p cannot equal 2. So there's our non-permissible right there. Okay? And then from here, we want to state it in simplest form. So we can go, okay, well, in our top, or in our numerator, we have a greatest common factor of 2p squared. So we want to find something that we can pull out of both of our terms. So 2p squared is as good as it's going to get for us. So we get p minus 2. And then underneath, you can see we have GCF of 8. So that's just 8. We get 2 minus p. So this is starting to look a lot like the situation we had in A, where we have p minus 2 and then 2 minus p. So instead of pulling out a factor of 8, I'm going to pull out a factor of negative 8. And that gives us negative 2 plus p. So we end up getting 2p squared, p minus 2 over negative 8, p minus 2. And so from there we can go, okay, well, these cancel out. And that leaves us with 2p squared over negative 8. And then we can also say, well, we can divide both of these by 2. And so for our final answer, get p squared over negative 4. Okay, so for this last one, we want to find our non-permissibles first. So we'll do that by factoring it, and it's a type 2 factoring problem. There's no GCF. So, okay, so what plus what is equal to negative 5, and what times what is equal to negative 24. Okay, so we find that we get negative 8 and 3, and negative 8 times 3 is equal to negative 24. So we get 6x squared minus 8x plus 3x minus 4. And we can go, okay, well, we can take out 2x of our first two terms. So that leaves us with 3x minus 4. And then just a positive 1 from our last two terms. So your two factors are 2x plus 1 and 3x minus 4. And so to find our non-permissibles, 2x plus 1 cannot equal 0. So x cannot equal negative 1 over 2. And the way we get this is we go, okay, so negative 1, negative 1. So we get 2x cannot equal to negative 1. Divide both by 2. So we get x cannot equal negative 1/2. And then for the other one, we solve it the same way. We go 3x minus 4 cannot equal 0. So we get 3x cannot equal 4. And then we get x cannot equal 4 over 3. Okay, so these are the two non-permissibles. So our work isn't done yet. We still have to actually factor and express in simplest form. So we notice, or we know that our denominator is 2x plus 1 and 3x minus 4. And then our numerator, we should notice that this is a difference of squares right here. Okay, so we'll get 1 minus 2x, 1 plus 2x. So now when we look at this, we should say, okay, well, x plus 1 and 1 plus 2, or 2x plus 1 and 1 plus 2x are the same thing because those are commutative operations. So these can divide out. And so this gives us 1 minus 2x over 3x minus 4. And this cannot simplify any farther. So this is our final answer. Okay. So let's look at example 3 now. So I really like this type of problem. So they're saying the area of a rectangular field can be represented by the expression 12a squared plus 25a minus 7. So this is the area. Okay. And then they say the length can be represented by 3a plus 7. This is the length. So if this is our field, we know that the length is 3a plus 7, and this is the width. So they ask us to write and simplify a rational expression which represents the width of the field. So we say, okay, well, we know that area is equal to length times width. And since we're looking for the width of the field, we can go, okay, well, width is equal to area divided by length. And we know the area, and we know the length. So we can go 12a squared plus 25a minus 7 all over 3a plus 7. Okay? So from here, because they want us to simplify it, we need to factor the numerator and then see if we can actually simplify it. So let's go and write that over here. So we go, okay, well, 12a squared plus 25a minus 7, that's a type 2 factoring problem. So we're going to say, okay, well, what plus what is equal to 25, and what times what is equal to negative 84. And we find that our two factors are going to be 28 and negative 3. So we have 12a squared plus 28a minus 3a minus 7. Okay, so then from here, we go, okay, well, here we can pull out a factor of 4a, so that gives us 3a plus 7, and then a factor of negative 1, 3a plus 7. So our two factors in our numerator are 4a minus 1 and 3a plus 7. So we can go and write that right here now. So we go 4a minus 1, 3a plus 7. I'm just going to put an arrow so we know where it's coming from. All over 3a plus 7. Okay. So now we can look at this and say, well, 3a plus 7 can be divided out of both. And so for width, we get 4a minus 1. Okay. So for the next part, they say if the perimeter of the field is 54 meters, determine the value of a. So we know the equation for perimeter is 2 length plus 2 width. Because all the perimeter is this side plus this side plus this side plus this side. So we can say, okay, well, we know that the perimeter is 54, and we know that our length is 3a plus 7. So we'll go 2 times 3a plus 7. And then we know our width is 4a minus 1. Okay? So all we get to do is expand it and then simplify. So we'll go, okay, 54. And we want to distribute that 2 into both of these terms, and this 2 into both of these terms. So we get 6a plus 14 plus 8a minus 2. Okay? So we can add 2 and subtract 14 from both sides. And that will give us 42. And if we add 16 and 8, that will give us 14a. And so if we divide both sides by 14, we get that A is equal to 3. That's our final answer. Okay. And then for part C, they say the field has to be treated with fertilizer at a cost of $2.40 per square meter. Calculate the cost of the treatment. So because they say square meter, there should be like a bell going off that says area. So we already know our equation for area. We had it given to us right in the beginning. So we're going to go, okay, well, area is equal to 12a squared plus 25a minus 7. And so we're trying to figure out how much square meters our area actually is. And so we were given A in the previous question, or we figured out A in the previous question. So we can substitute A is equal to 3 into our equation. So we'll go like this. 12 times 3 squared is 25, 3 minus 7. So we're just taking that A and substituting it in. So then from here we go, okay, well that's 12 times 9 plus 75 minus 7. So area is equal to 176 meters squared. So now that we found our area, we have to figure out, okay, well the cost is $2.40 per square meter. So we just go, okay, well cost is $2.40 per square meter, so times 176 meters squared, and we get the cost is $422.40. Okay? So, for example number 4 now, I say simplify where possible and state the non-permissible values for x in terms of y. So, again, first things first, non-permissibles come first, and then simplify. So let's do A and C. So we go, okay, well, x minus y cannot equal 0. So we know that x cannot equal y. There's our non-permissible. Okay? And then we want to be able to simplify our problem. So we go, okay, well, this is kind of like maybe one of those opposite problems where, you know, the top and the bottom. So we'll take out a -1 here, and that gives us minus x plus y over x plus y. And we can look and be like, oh, well, or under x plus y. And we can look and be like, oh, well, that's still not the same. So we know that's not right. And so what we actually have here is that there's no farther simplification. So no farther simplification. Okay. And then for C here, we have, okay, well, to figure out our non-permissibles, let's see, we have, this can be factored, so we can take a GCF of 3 out of the bottom, so let's go bottom. So we'll go 3x4 minus y to the 4th, and we say, oh, well, now this is a difference of perfect squares, so we go 3x squared minus y squared, x squared plus y squared. And then we can look at it again and say, well, this here is still a perfect of different squares. So we get to do it again. We go x minus y, x plus y, and x squared plus y squared. So to find our non-permissibles, we're going to go, okay, well, x minus y cannot equal 0. So x cannot equal y. X plus y cannot equal 0. So x cannot equal -y. And then we have x squared plus y squared cannot equal 0. So we'll go x squared cannot equal -y squared. And then we'll take the square root of both. And, oh, we have a problem. We have -y squared underneath the square root sign. So we know that this is not considered a or permissible solution because this is not even a real number. We learned in the last unit that we cannot have negative numbers underneath that square root sign. So this isn't even going to be included. So our two non-permissible numbers are just y and negative y. So now we get to try and factor this guy, or simplify it. So I'm going to write this out the long way, because I sometimes find it's a little bit easier to see things. So we'll go 6 times x plus y times x plus y. And then on the bottom we have 3, x minus y, x plus y, x squared plus y squared. Like that. Okay. So now we can look at this and say, well, we can cross out an x plus y in the top and the bottom. But we still have to keep this one here because we only have one on the bottom, so we can only divide it once. So that'll give us 6 x plus y over 3 x plus y, x squared plus y squared, like that. And then we can look at this and say, well, we can divide both the top and the bottom by 3, and that'll cancel this out. And it won't cancel it out at the top, but it'll reduce it. So that gives us 2 x plus y over x plus y, x squared plus y squared. Okay? And it can't be simplified any farther. So this is our final answer. So our final answer is 2 times x plus y all over x plus y multiplied by x squared plus y squared. With our non-permissibles, x cannot equal positive or negative y. Okay, so this is lesson number 2. So our homework is 1 to 4 and 6 to 8. So 1 to 8, omitting number 5.